Okay. So let us start with something called as adaptive Huffman coding. So in last few classes we have finished off with the process of Huffman. We know how to deal with it, and we have also found out that that is an optimal coding that we are all aware of for source coding purpose. But one very important observation that we all must agree with respect to Huffman coding is that, or for that matter any coding for that matter, is that we require, this is basically the shortcoming of Huffman and why we are going for an adaptive Huffman. So the main reason is that a prior knowledge of the probabilities of the symbols is needed, or rather essential, to form the code words. So this we all agree, I guess, that for any of the source coding, whatever we have done so far, we require a prior knowledge of the probabilities of the symbols, and hence we were rearranging it in the descending order, and then we came across different methods to find out the code words. But not always it is a possibility that we always know a prior probability of the symbols which are generating some alphabets, or the probabilities of a codes, how it is being generated. So what we need is, we need an adaptive solution where a dynamism should be there, that as and when the symbols are appearing, they should be following certain process in making the code words which are adaptive also in nature. Or in general, where we don't require the probability at which the symbols are appearing. Am I fine with this? Okay. So based on that, we will consider this for the adaptive Huffman. Naturally, the word adaptive symbolizes that where we are dynamically changing altogether. So let us do one by one what are the components to an adaptive Huffman coding. The first thing is, we'll use a problem where we'll take care of all the possibilities for our adaptive Huffman coding after going through the steps which are required. First step is, consider not just write what I'm looking at here, writing over here. I'll explain each and everything later. Not yet transmitted. Or in short we call it NYT node, which will have two components, namely an NYT or a not yet transmitted node should look something like this. One half is X of I, the lower half is Y of J, where X of I is indicating, or rather we can keep it same, both this two is I. Xi is node weight and Yi is node number. So first step is, consider a not yet transmitted node which will have the two components, namely one is the node weight and the other one is node number. What is node weight, what is node number, we'll come to that later. The condition will be such that, second point, the condition of Xj or Xi in this case, so X1 should be X2 should be greater than X3 less than X of 2n minus 1. Y1 similarly will be Y2 less than Y3 less than equal to Y2n minus 1, where n is the number of symbols which are available. Again, don't come to conclusion what are these, just write for the time being. We'll come to this all later. So this is the second one. Now, third point is initial node or NYT. We'll refer to this as NYT from further after this. NYT is always considered to be 0. This please highlight on this point. This is a very crucial point which will be referred at different point. So the initial node or NYT is always considered to be 0. Okay. Fourth, form a binary tree using the technique. I'm drawing it and I'm explaining it after that. These are called as you know it might be, this is external node, sorry. And these are the internal nodes. We'll see what are these components, what is internal node, what is external nodes. For your reference, already I guess many of you might be knowing it. For internal nodes, you at least write that for internal node, it consists of leaf node, and external nodes are which do not have leaf. Everything will be clear after with an example. This is the theoretical part. So we will form a binary tree using a technique where we will have one internal node. Internal nodes I will refer to as a circle, whereas external nodes will be considered to be a box. Okay, this is a convention. We will follow that convention. Now, the weight, suppose you have x1, x2 like this. So, your internal node will have the weight as x1 plus x2. That's how we are going to go one by one. In each level, when we are setting the node weight, we have to consider each of the external node. We'll just add and we'll give it submit there. So that is the rule that we are going to follow. Along with that, we have to follow one very important and very relevant process since we have introduced node weight, that binary tree will be expanded as per following rule. That y1 is less than y2 and x1 should be less than equal to x2. That means the concluding part which I ask all of you to write. I will make a star here. I will write it black. Left side node weight. Left side node weight should be less than the right side node weight. Otherwise, swapping is necessary. Please make a star on this particular slip. First step is the star I told you. The first initial NYT will always have a node 0, node weight 0. And the second point is this one. These two, the others are also will be used, but even that is a process. But these two are very important steps. We'll see that with an example. And third but not the least, how to calculate the node number. Okay? last point, 6th point. The node number is given by total number of, or node number, or the total number of nodes, if I consider, is given by 2m minus 1. Please make a box in this 2m minus 1, where m is number of alphabets. Okay. So if it is a binary symbol, we have 2 alphabets. So the adaptive Huffman coding is much simpler. So what we are going to do is we'll try with the worst case, and we'll consider in most of the cases that m is 26. That is the normal English alphabet. So if that is the case, so m if is equal to 26 for English language, then your node number, the maximum node number, can be 2 to the power 26 minus 1, 2 multiplied by 26, that is minus 1, which is 51. So we'll consider this, make it also a node, that whatever happens, this is our maximum node number that can happen. Because for most of the cases, we'll refer to it with the English alphabet. We'll not only focus on the binary digit in this case, unlike to the previous cases. Okay. Now we get directly to a numerical. We'll try to update the whole listing based on the nodes. So let us do it. Keep this with you. I don't need it for the time being. We'll take care of one numerical. The question is, the message what we have is AARD VARK. Okay, using the adaptive Huffman coding, update, create the tree or the binary decision tree for the message. We will not do the encoding. If time permits, we will do it. If at all we are not doing it, we will at least update. This is the update process that we are explaining now. After that, the encoding will come. If time permits, we will do the encoding today, or we will come tomorrow, we will continue. Okay? We will take time. We will take time. Easily we will do it. So the first point is, so step 1, we will start with the NYT node. Okay. So NYT node, if it is, we will write this way. Left hand side you write NYT. Please follow the convention. See the convention I am doing. We will put a 0 over here. We will put 51 as the node. So we are starting from this point where we haven't not received anything, but we have to start updating it. So the first thing that we will write, we will start with a null or not yet transmitted node, and we will specify like this. Now the second thing comes in. So here, why it is 0? Because there is no weightage given. There is no leaf node to it. So that's why it is a 0. You will soon find it will need to be updated as and when the bits comes in. So the first node will always be 0, and this is my node number because we know we are using the English alphabet, so the maximum number should be 51. So that's the specification. Now A appears. So I'll just mark it with some colors maybe. So this first A appears. What will happen to it? So the step is, we will create, I'll write first, okay. So when A appears, let me just write it for the first time because this will be repeated again. Appears for the first time, because later on when you will refer to this node, it will be easier for you to understand. You will soon forget after I do it. It will be easy when I am doing it, but it will be difficult for you to do it. So write the statement. When A appears for the first time, break the NYT to a new NYT and the encountered symbol. So the first thing is, whenever a symbol appears, forget about A, it can be anything. But here, since A has appeared, when A appears for the first time, break the NYT to a new NYT and the encountered symbol. First, we'll write again, if it appears again. Suppose in this case, if A appears for the second time. So if it appears again, then increase the symbol weight by 1. Okay. If it appears again, each here means the symbol that we have referred to. So suppose A has appeared, second time again A appears, then what we have to do? We have to update it by 1. We'll see once again. Now, let's see what happens when A appears there. So the step involved here is, so I'll go down. So I'll write it here. Okay. So you have A, R, D, V, A, R, K. This is a very important example because it contains all the possibilities of an adaptive Huffman code. That's why you will find in the internet also they explain it using this particular example. So I'm taking this as an example. So first time A appears, so we already have that NYT. So the first step is we need to break it. So how will I break it? So we'll have this one as NYT. So this will be a new node. We will have another node. I'll write A and that's it. So if you can go back to the rules that I told you that form the binary tree here. So it appears to be the same. So when you are breaking it, one half will always have an NYT, the second one will have an internal node, and we have something as an external, another external node right hand side. So if in the same way, we are forming a binary tree over here where the first NYT has been broken down into one NYT and the symbol that has appeared. Clear? Okay. Now, the NYT node will always have a value which is 0. It will always have a node which is 0. A has appeared for the first time. Right? For the first time. So, I'll write inside a 1. So, this is my x1, this is my x2. So, your node weight for this node will be 1 plus 0 and this should be 1. Pay attention to details what I am doing. When A appears for the first time, I am breaking the initial NYT into two halves by making one NYT and the new symbol that has appeared. And they need to be connected with an internal node. That's why we have made sure that this internal node appears. Along with the node weight, that will be the summation of the weight at that particular stage. How about the node number? Now this will be my 51. This will be my 50. This will be 49. So, whenever we are looking at this is when A has appeared. So, what will happen? So, I will just mark here that A has appeared. Is it fine for the time being? Is it fine for all? If you have any doubt, please tell me. Because it takes time to understand the whole thing. Now comes the second node. So, we have the second symbol which is A. So, I am taking this A. And we have this as a configuration. So, what I am going to do is, we will go back to the solution that if it appears again, then increase the symbol weight by 1. So, simply what we are going to do is, when the second A appears, so this is when the second A appears, I will write just this way. So, what will happen? I will keep this NYT as it is, which will have a 0 inbuilt. The tree will be remaining as looking same as this. Okay. But A has appeared twice. So, your weight will be 2. 2 plus 0, you should update this as 2. And as far as the node number is concerned, 51, 50, 49. Is it fine? So, when two symbols appear, now this example is a way where what will happen, all the cases as I told you, all the cases will happen. So, first symbol comes in, we did one tree. Now, the second symbol comes in, we will update the tree. Now, what will happen to R? Can you do it with me? What will happen when the third symbol or this R appears. I'll do it with some other color. We are existing somewhere over here. So I'll just write figure 1 maybe. I'll draw this as figure 2 so that we can refer it clear. So we are at figure 2. Now R appears. What will be the structure? You just tell me. What will be the structure when R appears? So we'll just go one from down. We'll go. So we'll have something. This is when R appears. Okay. So this will be n by t. Okay. Naturally, it should be 0 or the node weight, whatever it is. After this, what will happen? Just follow this one. Just follow this figure 2. The same thing will be repeated. So that is already there with figure 2. Now the new node has come. Is it already present in the node? So we have to break the NYT into two halves. One is another new NYT and this next node will be the new symbol which is R. So maybe we will have a scenario like this. We will have scenario like this. Is it fine for all? We are breaking the NYT. So as if this one, this subset, if I consider this set, this is nothing but what we have done over here. Same thing. Now, can you tell me the weight? So if this is 1, this will be the node weight. Node weight. How many times it has appeared? 1. 1, correct. What will be the node weight here? 1 plus 1. 1 plus 0 is 1. What was the original node weight of A? 2 plus 1? 3. Correct. So, we will go for the node numbers. So, this will be my 51. This is already given as 50. This was my 49. So, the next half, right hand side will be given as 48. This will be 47. Any doubt? Any doubt? Anyone? Basically, we are following a convention. Nothing more than that. You can see here we have mentioned as 51. So, right hand side we are keeping the greater side. The left hand side we are keeping the lower half. 51 is the maximum we can keep. As I told you, 2m minus 1. So, the right hand side we are making a convention that the right hand side will be just below 51. And the other half is 49. Now, if you come over here, this is already 49. So, you can keep this as 48. You can keep this as 47. So, suppose the next time comes in, suppose here at R we have two nodes. So, you can keep the right hand side as 46, the left hand side as 45. Because 47 has already appeared here. Something like that. It will go on. You will see that. So, is it clear with this? Now, so this is when R appears. So, R is done. Now, let's see what happens when D appears. Can anyone do it for me? I mean, we'll give this as figure 3 as reference. Now, what happens when D appears? Okay. So, we have figure 3 now with us. Same way, whether D has appeared before. D has appeared before? No. So, I need to spread or I have to break or divide the NYT into again one external node and one another new NYT. So, I'll start from the N. Maybe I'll use a black color. So, first, whatever happens, make sure you have this NYT placed. Don't write the node numbers right away because node number you can only give after the tree is made. So you have 0. Naturally, you will require something like an internal node and you will simply blindfoldedly you can actually write the new node as the right hand side. So you can write D. So this becomes the new node. So this NYT is now broken down into this half. So if this is the case, what will happen after this? What will happen after this? This will be circle. This will be a square R. This will be another circle. This will be E. That's correct. Can you imagine the scenario? What I did? I am just breaking down this NYT into two nodes. Those two nodes are here. This is the new NYT and the new entry as D. Is it fine? Is it fine? Just confirm me. I can wait for anything, right? So, tell me the node weightage one by one. So, first is this is 0. D has appeared once. 1 plus 0. R is 1 plus 1. This one 2 plus 2. Give me the node numbers. 51, 50, 49, 48, 47. This one 40, 46, 45. That's correct. Got it? So this is my position of binary tree when we are looking at D. So the data which was there, A, R, D. So we are transmitting the data. Please can you observe that we don't require the probability of the symbols. We are not looking into the probabilities of appearing of the symbols or the alphabets rather. We are only focusing on as and when it is required. We are just going on building up the tree. Okay. Can anyone give me what happens with the tree configuration when V comes in as the next element? We'll just write this as figure 4 and I'll go down. Figure 4. Error is there? How can you modify? Yes, you can. I am doing it separately, just for your own convenience. When I did it back home, I actually did a pencil. It's better to advisable. You can use a pencil actually. You can just drop in whatever the steps are. Then you can go on updating. That you can only do when you are expert in doing it. That's why I'm suggesting. It's easier for you to understand. That's why I'm doing it. I can do the final code also. Okay. So now V appears. Can anyone give me the tree from bottom to top? What will be the configurations we have? Okay, what I'll do is, again, V has not appeared anywhere. So it's a fresh entry. If it is a fresh entry, so in figure 4, wherever the NYT was, it has to be broken down into two halves once again. So the tree will remain almost the same, but it will look something like this. NYT, we'll put a 0 anyway. We have some node. We'll put V out here. We'll put something here. What will be the entry here? In the box? E, correct. Again we have another one. What will be here? Very good. What will be? Have we finished? Oh no. I think A will be there. So we put an A. Correct one. So this is the primary structure. We don't have the node number. We don't have the node weight. So we have to put that. So I'll put the node weight first. Once again, V has appeared first time. 1 plus 0. 1. D was how much? 1 plus 1? Very good. 2. R was 1. 2 plus 1? A is how much? A had 2. So 3 to 5. I am not writing the node number right away for the time being because it will be the same. It will be just 45. I think last time it should be 44, 43 I think. Leave out, for the timing leave out that. Now comes, you go back to the rules. When I said some rule as this rule number 5. Left side node weight should be less than the right side node weight. Otherwise, swapping is necessary. Keeping this in mind, if I go back to V, when the V has appeared, can we observe the same thing happening over here? You can observe that here, in this segment, we are observing a scenario where the left hand side node is having greater weight compared to the right hand side node. This is 3, this is 2. So it's violating the policy of the process. Also, you can observe one thing over here. If I consider this half, right hand side is 1, left hand side is 2. So in both the cases, it is violating the policy or the process of adaptive Huffman coding. So we need to do a swapping. Understood what we have to first identify? So this should be done at each step. Since till A to D, A, R, D, we never had experienced this, we haven't checked it. But if you can go back to the diagrams, you can check that the node weightage were all okay. That's why we never needed a swapping. But when we have reached over here, we are observing that we have a scenario that the left hand side weight is greater than the right hand side weight. So we need a swapping. How do we swap? Please be careful on this. So this is not my tree for V, where it appears. So what we are going to do is, I'll draw it over here so that we can compare. So we have this diagram. We will start from this. Okay. We will shift to this position. Right hand side we will put 3. Swapping. We are doing the swapping. Okay. 3. Now from 3 we have 2 on the left hand side, 1 at this side. So we will swipe again. So this becomes R, this becomes 2, this becomes 1, this becomes D, because here there was no problem. It will be following with the same process. This had NYT, this had V. D was how much? 1. Everyone followed what I did. You can do it at the back also. But this is for the first time I am doing it. That's why I thought of showing you this way. What I did, these are the positions where we need to change. Because in both the cases, in both red and the violet one, these are the 2 positions where the node weight is greater on the left hand side. So we will just have a mirror image of it. So what I did, I just switched over this 2 over here and we switched this 2 over here. The rest of the diagram will remain as it is, like we had done this. This is only to be done when the left hand side is greater than the right hand side. Is it clear? This side? Anyone having doubt? So now can you give the weightage? Node number, sorry. Node weight is already given. Can you give the node number? So what I'll do is 51, 50, 49, 48, 47. So this is 48. So 47 is given. This should be 46. This should be 45. This should be 44. This should be 43. Any doubt anywhere? Is it clear with the tree? Now you can understand why I told you on the very first end that I don't need any disturbance whatsoever. Each and every step needs to be calculated in the same manner. If I have reached V, if I go to the message, it was V, then what should appear? Again, an A should appear. can you do me a favor by creating the binary tree when another A appears? Because now this has become your figure 5. After swapping whatever the data, whatever the binary tree is, that is your latest figure or the updated one. That's why we are calling this as an updated process. Shatatul, tell me what problem here. R? Is it? Okay, let me see where R appears. Okay, R appears. Right hand side is greater, right? Right hand side is 2. Left hand side should be 3 is a summation of it. We will not see this. We will see these two branches. Yes, the leaf nodes. We call this as a leaf node. We will check this too. Now we check this one here. We are checking this. We are not going for the source node. We are just checking 3 and 2. We are checking 2 and 1. Okay, here. So if you have this figure 5 and now A appears once again. A appears. Can anyone give me the pattern by starting from NYT? Okay, let me just write once. Okay. So, should I be breaking down the NYT? From figure 5? Should I be breaking down this? No. Why? Because A has already appeared before. Correct. So what is the process? We have to update the node number. So what will be the node numbers? I have to draw it anyway. I can remove it, but for the timing what I'll do is I'll redraw it once, the figure 5. So this is my NYT. Just just give me the data once. Okay. I can't see. Okay, so this was something like 1. This was V 1. Then we had what we had. This was 2. Okay. Okay, this is 1. This was D. Then we had 3 over here, I think. This was R with 1. Okay. Now A. Okay, this is fine. This because this is I'll keep it blank, and I'll keep the A out here. So A was 2. Previous diagram A was 2, I think. A was 2. So the new entry will make it count to be 1 more. So I'll make this as 3. Okay. So A3 and this 3. So 3 plus 3, this should be 6. This, even if it is equal, we don't need to swap. Please remember, if they are equal, we don't need to swap. Even in the left hand side is equal to the right hand side weight, we don't need to swap anything. Okay. So again, if I go back to the node number, so it will remain same. 51, 50, 49. Tell me once, 50, this one, 48, 47. Is it matching? Is it matching? 48, this one is 46, 45, 44, 43. Good. So we have reached till A. What else we are left with? Next entry is R, I think. Next entry is R. So R has already appeared somewhere over here. I am not drawing it once again. So this half will remain same. So R needs to be updated. So if R is 2, so 2 plus 2, 4. 4 is right hand side, so it still remains as it is. So 4 plus 3 is 7. So it remains same. So I'll just update it here. Can I do it? Can I do the updation? Okay. Is it fine with you? So I'll just remove this one, this one, this one. So R will be 2. Okay. 2 plus 2 will be 4. 4 plus 3 will be 7. So you don't need to swap anything because the left and the right hand combination is also working. So this is when updated done for R, the second R to appear. Keep a track of the initial message. I'm not able to look at the whole page, but you keep a track. Next comes in is K. I think K comes in. K has appeared? No, K never have appeared. Can you give me the solution for K? What will happen when K appears? When you are at position of this nature. When K appears. So it's a fresh entry. Okay. So the first step is again that NYT needs to be broken down into two halves. One is the NYT, the other branch will be K. So I'll start from the end. So NYT 0. This is K, which naturally will be 1 because it has appeared for the first time. So we have broken down actually this half. We have broken down this half. Okay. So from here we will have something like some box, and we will have V over here. Okay. Then we have some box over here. We will have another D over here. Again, the node weight we are not writing because it will update itself. So D is appearing over here. This goes to something which is R. This happens to go to another node. Am I correct with? Is it fine? What I'll do is I'll just remove this for the time being because it will. So this is for the K that has appeared. Now furnish me the details of the node weight. Okay. So 1, 0 is given. We'll have 1. V was how much? 1. So 1 plus 1, 2. D was 1 already. So 2 plus 1, 3. R was already 2. So 2 plus 3 is 5. D was 3. So 5 plus 3 is 8. Do we need any change or the weights are same? Where? This is where there is a problem. This is the problem because in the left hand side we have weight which is greater than the right hand side. So we need a swapping only at that position. Clear? So if I redraw the modeling, so NYT 0 K, is K the last bit? Okay. So K, then we have, which one to swap? So after this we have V, okay. So D will come this side and 2 will come this side. So 2 will have V. Okay, so what I am going to do is, we will have something like this. From here, I'll give V. Okay, then we have this, from which I think the D will come. Then we have another circle. What will it be? R. Okay. Then we have another one. Give me the node numbers, node weight. So this is your 1. So 1 plus 0 is 1. V was 1. So 1 plus 1 is 2. D was 1. So 2 plus 1 is 3. Next, R was 2. So 2 plus 3 is 5. A was 3. 5 plus 3 is 8. Am I clear? Or anywhere error is there? Fine. Give me the node numbers. So this is 51, 49, sorry. 50, 49. This will be 48. This will be 47. This will be 46, 45, 44, 43, 42. So this is a complete tree of updating purpose. We haven't encoded anything. So I don't think we have time for the encoding. We'll start exactly from this point tomorrow, where we'll encode the whole message of AAA or AARD, whatever is given, with the binary digits. Right? So because ultimately we have to digitalize the whole system. So this is the updating process where we have observed that without the probability, we actually can update the binary tree and then we'll form the encoding or the code words for the same. Right? Thank you.